If you want to avoid making mistakes when using the elimination process to solve a system of equations, then add, don't subtract. And so what I mean by that is we need to get the variable to be the same for whatever variable we're trying to be, or whatever variable we're trying to eliminate, either x or y. However, if you're going to do subtraction, you want that coefficient to be exactly the same, both positive or both negative. I don't like to do that. I always like to be able to add my two equations together. So what that means is I need the coefficient to be exactly the same, one positive and one negative. So if you're going to go ahead and solve for x, you need to multiply everything by a -3. If you're going to eliminate the x, you'd multiply everything by -3. If you wanted to eliminate the y, you'd multiply everything by 2. Doesn't matter which one you do, I'll just go ahead and multiply by -3 so you can see what I'm doing. Okay, so all I did was multiply my top equation by -3. However, what that produced now is a coefficient for x, you can see, are exactly the same. One's negative, one's positive. Once I have achieved that, now I can simply just add the equations. When I get that, a negative plus a positive is always going to 0. 0 times x is just 0. So you can see I eliminated my y. It's much better to add a positive than a negative than doing subtraction. I'm just telling you guys, even though it's the same idea, students just make mistakes with negatives, especially when you have subtraction and negatives. It just doesn't work out very well. 3y plus a -2y is going to be a y. -30 plus 25 is going to equal a -5. Now I can just take this value, plug it into one of my top two equations. I always like to plug it into the one that's the most simplified, which in this case would be my top equation. Make sure to use parentheses, right? This is minus x minus y, so x minus a -5. So that's going to turn into a x plus 5 equals 10. Subtract 5, x is equal to a 5. So my system is x equals 5, y equals a -5.